Hello, everybody. So, today I'm going to talk about the basics of circular motion. Now, circular motion is basically the movement of an object along the circumference of a circle or just the rotation along a circular path. And there are many definitions we'll have to know in this chapter. So, the first definition you will need to know and remember the whole time is angular displacement, which is basically the angle swept by the radius vector at a given time. Like, let's suppose an object moves from point A on the circle to point B on the circle. So, obviously, there's an angle that it swept to get there. So if you want to calculate that angle, we'll have to divide the arc length by the radius, and that'll only be measured in radians. Now from that we can derive that what is the angle swept when the whole circle is traveled. So obviously the length s is equal to 2 pi r, which is our circumference, and r is the same as usual. So while calculating it, we'll get 2 pi radians, on the basis of which we can say that 2 pi radians is equal to 360 degree, and furthermore pi radians is equal to 180 degree. So 1 radian is basically equal to 57.3 degree. Now one definition we're gonna have to remember the whole time, and it'll come again and again, is that of radian. So it's basically the angle subtended at the center of the circle by an arc whose length is equal to the radius of a circle. Because in this case, S is equal to R because the arc length is equal to radius. So when we divide S by R, we'll obviously be getting 1 radian. That's also why we can say this. So as you can see here, there are many radian to degree conversions and degree to radian conversions. And it's also recommended that we always express degrees as a multiple of pi when we're converting it to radians. So jumping off to the next part, we have now arrived angular velocity. Now the unit of angular velocity is always omega, and the unit in which it's expressed in is radian per second, because it's the rate of change of the angle swept. Now as we know, delta theta is always equal to s by r as per the previous thing I just taught. So if we want to derive this for velocity, which is a change in displacement by time taken, we'll obviously write delta theta is equal to s by r. But velocity is equal to s by t, and we have s by r. So let's suppose we divide it. So if we plug s by r in this, we'll get s by rt. And in order to make this equal to this, we're gonna have to get rid of the radius here. So if we move on, delta theta is equal to s by r, but omega is equal to s by r divided by t, which is what we got it, s by rt. So if you want to make it equal to velocity, we're gonna have to multiply this omega part into radius, for which we'll get this formula, which is v is equal to omega r. So basically, from that we can conclude that angular velocity is the rate of rotation, and rate of rotation is the same thing as frequency, which is expressed in hertz. As we can see here, frequency is the number of rotations divided by time taken. And as 2 pi radians is always equal to 360 degree, it is one full rotation, we can write omega is equal to 2 pi f, on the basis of which we can also write omega is equal to 2 pi into 1 by t equal to 2 by t, because t is the period for one full rotation and is always expressed in seconds. So now we're going to talk about how Newton's first law is also involved in this chapter. So as we know, the first law states that the object remains at rest or in a state of uniform motion unless an external force acts on it. So for the case of an object moving at a steady speed in a circle, there must be an unbalanced force. Like, as you know, if it all needs an unbalanced force to even move in the real world. So a good example of that would be the Earth orbiting the Sun. And what is the unbalanced force here? The gravitational pull of the Sun. That is also known as centripetal force, for which we'll be bringing in the second law of Newton very soon. So, since the object is constantly changing direction, we can say that it is accelerating because, of course, velocity is basically two things, the magnitude and the direction. Now, the magnitude is obviously constant, but no, the direction is not constant. So, since we can say that the velocity is changing in that respect, for which it's also accelerating. So, if we have to find something for centripetal acceleration, we are given that delta v is the change in velocity, and we look at this diagram on the circle. Ignore the straight line. So, like, if it's moving from this point C to point D, we say that there's a change in velocity. Don't be confused. So, this velocity and this velocity is literally the same thing, but here it's showing that's delta v. So we want to calculate delta, like if you want to calculate theta, sorry, then we're gonna have to divide delta v by v as per the formula s by r. So from this we can derive that delta v is equal to v into delta theta, which is basically velocity into the change in theta. And we are given it. There's already a general formula that acceleration is the rate of change of velocity, so it's delta v by delta t. And if we plug in delta v, we get a is equal to v into delta theta by delta t. So it was already explained that omega, which is our angular velocity, is equal to delta theta by delta t. So this is exactly what's happening here. Delta theta by delta t is our omega, for which we'll write acceleration is equal to velocity into omega. But we also know that v is equal to radius into omega, for which we can derive that omega is equal to v by r. And when we plug in omega into this equation, we get v into v by r, which is v squared by r, for which explains the whole formula of acceleration. So the final part of this basic video is that the rate of change of tangential velocity is the right way to describe centripetal acceleration. So, as I mentioned earlier, for any object to move on a circular path, we're gonna need a centripetal force, for which we have brought in the Newton's second law, which is F is equal to ma. Like, and we already have that force equal to mass into acceleration. So same thing we're gonna bring in here, because acceleration we have is v squared by r. Okay, and we already have mass, we have force, so therefore we have that force is equal to mv squared by r, and F is equal to mr into omega squared. These are important formulas to remember. So finally, we must conclude that centripetal force is basically the force needed for an object to move in a curved path. I'll be making more videos about this, and if any of you have any doubts, please comment and please do subscribe. Thank you.